In this chapter, we're going to solve a system of two linear equations in three different ways. We're going to solve it by graphing, by using the substitution method, and by using the elimination method. And then we'll do some examples of solving two linear equations to solve some applied problems. Every linear system is equivalent to one of the three following cases. So if we have two lines, exactly one of these three things will happen. We have case one, where the two lines are parallel, in which case they never intersect and there's going to be no solution. We describe this situation as being inconsistent independent. The second possibility is that the two lines intersect exactly one time. That point of intersection is going to be the solution to this equation, and in this example it would be the point 0, 4. It will have exactly one solution, and we call that consistent independent. The last possibility is a little harder to visualize, but imagine that we had two lines, but they were algebraically equivalent. That is, they lie exactly on top of each other. Then every point that lies on both of those lines would be a solution, and we would have an infinite number of solutions. And we call this case consistent independent. All right, let's go ahead and take a look at example number 1. So example 1 wants us to solve the following linear system: x plus 2y equals negative 2 and negative 3x plus 4y equals negative 24 by graphing. So the easiest way to graph a line is to write it in slope-intercept form. So if I have x plus 2y equals negative 2, I minus x, I get 2y equals negative x, take away 2. Divide every term by 2, and I get y equals negative 1 half x, take away 1. So then I have my slope, and I have my b value, so that is the y coordinate of my y-intercept. So I start at 0, negative 1, and I have a slope of 1, negative 1 half, so I go down 1 over 2, down 1 over 2, left 2, up 1, and so forth. And then I connect the dots, and I get a line that looks something like this. And then I rinse and repeat for my second equation, and I have negative 3x plus 4y equals negative 24. So I add 3x, I add 3x, and that gives me 4y equals 3x, take away 24. And I divide each term by 4, finally getting y equals 3/4 x, take away 6. So once again, I have my slope and my y-intercept, so I start at the point 0, negative 6. I go up 3 and over 4, up 3, over 4, and I connect the dots. And then I have my solution, which is right here, which would be the point of intersection of those two lines, which is at the point 4 and negative 3. So the solution is 4, negative 3. We can verify this algebraically by plugging the solutions back into the original equation. So I had x plus 2y equals negative 2. And if this is a solution, when I substitute x and y into the original equation, I should get a true result. So that would be 4 plus 2 times negative 3, and I want to know, does that equal negative 2? So that's 4 minus 6, which is indeed does equal to negative 2. But to be a solution to this linear system, it must work in both equations. So if I check my other equation, I had negative 3x plus 4y equals negative 24. And once again, I substitute in. So I have negative 3 times 4 plus 4 times negative 3. And we want to know, does that equal negative 24? Well, it's negative 12 minus 12, which indeed, again, is a true statement. So the point for negative 3 is indeed a solution to that linear system. Let's go ahead and take a look at example number 2. So I wish to solve x plus 2y equals negative 2, negative 3x plus 4y equals negative 24 by substitution. So you might notice this is exactly the same problem that we did in example 1, but this time we want to use a different method. So for the substitution method, the first step that we're going to do is we need to isolate a variable in either equation. And which one we isolate will not change the solution to the linear system, but if possible, we always want to isolate a variable that has a coefficient of plus or minus 1, because that will make the computations easier. That may not always be possible. In this case it is. The x here has a coefficient of plus or minus 1, and the reason that will make our lives simpler is when we're solving for that variable, if we only have to divide by plus or minus 1, we'll never introduce fractions, which will make it a little more complicated. So the first thing we want to do is decide which variable to isolate. So the x in equation 1 is the best variable to isolate. So we have x plus 2y equals negative 2, and we minus 2y, we minus 2y, and we get x equals negative 2y, take away 2. So then, step 2 is we substitute the variable that was solved for in 1 into the other equation. And what I mean by that is the one not used. In step 1. So we're going to substitute that in, so we know x is the same as negative 2y minus 2. So then we substitute that into the second equation. We have negative 3, then x is the same as negative 2y minus 2 plus 4y equals negative 24. Step 3 now is we simplify and solve. So we're going to distribute into our parentheses. Negative 3 times negative 2 gives us positive 6y plus 6 plus 4y equals negative 24. So we minus 6 from both sides of the equation and collect our like terms. 6y plus 4y is 10y, and negative 24 minus 6 is negative 30. Divide by 10, divide by 10, and we get y is equal to negative 3. So now, to finish, we need to find x. We have only half of our ordered pair. So then step 4 is we solve for the other variable by using the equation from step 1. So our equation from step 1 was x equals negative 2y take away 2, but we just found y was negative 3. So we substitute into that equation. We have x equals negative 2 times negative 3 take away 2. And negative 2 times negative 3 is positive 6 minus 2 gives us 4. So now we have y equals negative 3 and x equals 4. So the solution is an ordered pair x comma y for negative 3. So we'll notice that this is exactly the same solution we got in example number 1, because the system of equations was the same. What this shows us is that the method we use to solve a linear system does not change the solution to the linear system. Alright, let's take a look at our next example. So example 3 is once again the same linear system, but this time we know what the solution is because of what we just talked about, but we were asked to use another method. So this is our third possible way to do this. So we want to solve this time by elimination. So elimination works based on the premise that we can add the same thing to both sides of the equation. What that means is that if we line equations up at the equal sign, since negative 3y or negative 3x plus 4y is the same as negative 24, I could add negative 3x plus 4y to one side and negative 24 to the other side because they're the same, and then add those together and get a new equation. The goal of elimination is we need to make a variable have equal but opposite coefficients. So if I look at the x's, this x has a coefficient of positive 1, and this one has a coefficient of negative 3. They're opposites, but they're not equal. So if I added them up, 1 plus negative 3 would give me negative 2. The x's wouldn't eliminate. Similarly, if I added these up, 2y plus 4y, if I added those up, I would get 6y, which also wouldn't eliminate the y's. So our goal is to find something to multiply one or possibly both of the equations by to make the coefficients equal but opposite. So the first step in using the elimination method is we need to choose a variable to eliminate, and there is no wrong choice here. So I'm going to choose the variable y, but if you choose x's, it'll make it look a little different, but at the end you will get the same answer. So step 1, we choose a variable to eliminate. as I said, for no reason whatsoever other than I chose y, that's the one I'm going to pick. And then step 2 is we find the least common multiple or the LCM of the y coefficients. In this case, our y coefficients are 2 and 4. So the LCM of 2 and 4 is 4. And then step 3, we fix each equation by multiplying both sides by a number to get equal but opposite values of the LCM. So we want to eliminate y's. Our LCM is 4. So if I multiply equation 1 by -2, positive 2 times -2 gives me -4, which is the opposite of positive 4. So we multiply equation 1 by -2, and that's going to give me -2x minus 4y equals 4. And then the second equation doesn't need to change at all. So then I'm going to have the negative 3x plus 4y equals -24. And we should note the y's are equal but opposite. So now if I add these two equations together, they eliminate when added. And then I have -2x plus -3x is -5x. And 4 plus -24 gives me -20. And I solve for x, -5, -5. And that gives me x is equal to 4. So then, finally, we substitute the solution from 3 into either original equation. So if we substitute it into the first equation, that would be 4 plus 2 times y is equal to -2. So we minus 4, and we get 2y equals -6, divide by 2, divide by 2, we get y is equal to -3. So then our solution, once again, is 4, -3. it's time for you guys to do a U try. And notice, we weren't told any particular method to do. And remember, whether we do substitution, elimination, or graphing, we will always get the same solution. Alright, well, I'm going to use elimination. So in order to eliminate the x's, I need the LCM of 2 and 3, which is 6. So I will multiply the first equation by -3, and I will multiply the second equation by +2. And that would give me -6x plus 9y equals -30, and +6x minus 4y is equal to 90. If I add the two equations together, the x's eliminate. 9y plus -4y is 5y equals to -30 plus 90 is 60. So then, divide by 5, and that gives me y is equal to 12. Now I substitute that back into either original equation. So in equation 1, that's 2x minus 3 times 12 is equal to 10. So 2x minus 36 is equal to 10. Add 36, we get 2x equals 46. Divide by 2, and we get x is equal to 23. So our solution is the ordered pair 23 and 12. Alright, let's take a look at our next example. So we want to solve x minus 3y equals 1, negative 2x plus 6y equals 5. So once again, let's go ahead and do the elimination method. So to eliminate my x's, I'm going to multiply everything in equation 1 by 2, and that gives me 2x minus 6y equals 2. My second equation is then fine, so I have negative 2x plus 6y equals 5. And then I want to add the equations, and my x's eliminate as I expected, but something unexpected happens. The y's also eliminate, so the left-hand side becomes 0, and then 2 plus 5 is equal to 7. And now I'm left with the equation 0 equals 7. Well, that's not a true statement. That's false. So when this happens, the system has no solution. And if we think back to the very beginning, this was our case when we were inconsistent, independent. If we go back to the very beginning, that would tell us then inconsistent independent means these two lines are actually parallel. So if we were to graph x minus 3y equals 1 and negative 2x plus 6y equals 5, we would find out that the two lines are parallel. Let's take a look at our next example. So example 5, we wish to solve 2x plus 3y equals 6, 4x minus 6y equals 12. Once again, we can eliminate our x's by multiplying this equation by negative 2, which gives us negative 4x minus 6y equals negative 12. And then we have positive 4x plus 6y equals 12. And when we add our equations together, Once again, just like in the previous example, both the x's and the y's eliminate, so we get 0 equals. But this time, on the right side, we have negative 12 plus 12, which is also equal to 0. Well, 0 equals 0 is a true statement. When this happens, it means that we have an infinite number of solutions. And if we go back to the beginning, we called this consistent independent when we had an infinite number of solutions. What that really means is that these two lines are actually the same line, even though at first they look a little different. And if you take equation 2, if you divided every coefficient by 2, 4 divided by 2 is 2, 6 divided by 2 is 3, and 12 divided by 2 is 6. We see that they are indeed the same line. So we call this consistent dependent. When we have the consistent dependent case, we need to parameterize our solution. So to parameterize the solution, we need to solve either equation for y. And the reason we say either equation is, as we just talked about, they're actually the same equation. So you'll get the same thing regardless of which equation you solve. So we have 2x plus 3y equals 6, and minus 2x, and minus 2x. And that gives me 3y is equal to negative 2x plus 6, divide by 3, divide by 3, divide by 3, and we get y equals negative 2/3 x plus 2. So then, the solution is an ordered pair x comma y, and we have x, but then we have our y value that we just solved for. Y is the same as negative 2/3 x plus 2, so negative 2/3 x plus 2. And that would be the solution for every real number x. Alright, so let's go ahead and take a look at example number 6. You invested $7,000 between two accounts paying 6 and 8% annual interest respectively. If the total interest earned for the year was $480, how much was invested at each rate? So the first thing we need to do is define a variable. So let's let x be the amount invested at 6%, and we're going to let y be the amount invested at 8%. Our model for simple interest is going to be I equals P times R times T. So then we know a couple of things. We know we invested $7,000 between two different accounts. So that means, first of all, that X plus Y, the amount in X, the amount in the second account, the amount in the 6% account plus the amount in the 8% account has to equal the total amount, which is 7,000. Then we can use this equation because the next thing tells us about the interest. So the amount of interest is the amount in the account, the principal times the rate times the time. So the amount in the interest from the 6% account is going to be the amount invested at 6% times the interest rate, which is 0.06, times time, which is 1, plus the amount invested at 8%, which is y, times the interest rate, which is 0.08, times the time, which is 1 year, which is 1, has to equal the total interest for the year. So that gives us 0.06x plus 0.08y is equal to 480. We need to solve this linear system for x and y. So I need to eliminate a variable. So I have a positive 0.06x and I have an x. So if I multiply everything in equation 1 over here by negative 0.06, that would give me negative 0.06x plus, well, negative, because it would be a negative y, so negative 0.06y is equal to, and negative 0.06 times 7,000 is going to be negative 420. So then I add my equations up, and the x's eliminate as they're supposed to, and then I get 0.02y is equal to 480 plus negative 420 is 60. Divide by 0.02, divide by 0.02, and that gives me that y is equal to 3,000. So if y is equal to 3,000, I substitute that into the other equation. So I would get x plus 3,000 equals 7,000. So I minus 3,000, I minus 3,000, and I'm left with x equals to 4,000. So there was $4,000 invested at 6% and $3,000 invested at 8%.